turning Python into a calculator and learning all the arithmetic operators. So in the last one, we did cover a couple of operators already. So just a recap, we mentioned that operators are essentially these signs right here that are used whenever we're doing calculations, right? So this becomes the operator, this becomes the operands. We did cover addition, which was the addition of values, subtraction, subtracting values from each other, multiplication, and division. And in this one, we'll be continuing from the modulus, which is used for calculating reminders. Um, I'll just quickly scroll down to the code for that one. And I do believe that we'd already covered an example where we had to split up a couple of things. So we'll start from that example and continue from there. So we did mention that, again, modulus was often used whenever you're trying to divide something and you're more interested in the reminders, right? And to give an example, we mentioned that when you when you write code such as print 10 modulus 3, the answer that you get is the 1 right here, right? Because 3 times 9, 3 times 3 gives you 9, and your remainder is 1. All right. And we also did do this example here where we mentioned that if you started with a number, for example, 7, and you did write the code to say, so for example, if a number modulus 2 equals 0, print even, that would print even. If you added the else statement and said print odd, it would print odd if that number was odd, right? So since 17 is an odd number, we'd expect it to print odd. All right, let's continue on then to floor division, right? So floor division, unlike the one that uses a single forward flash, which is the one for floats, this one performs division, then runs down to the nearest whole number, right? Let us say we have this example here, right? Print 10 by 3. Again, if you already knew this, feel free to forward to the later section with things that you haven't covered yet. So if you have such an example as print 10 divided by 3, this would essentially give you the answer rounded down to the whole number. So I'm just going to go ahead and copy this code right here, and we'll add it to this section here. Right. Okay, so let us run this code here. So in our terminal, we see that we've gotten the result as 333. So which means if we divide 10 by 3, we would get 3.333, but would round it down to the nearest whole number, which is 3. And if we had 12 divided by 4, this gives us exactly 3. So we would get the result of 3, which we have here. And also if we had 7 divided by 2, would get 3.5, and running it down would get 3, right? Again, the print statement tells Python to print the result to the console. That's why we are seeing it here. All right, so using a real world example, let us say you have a couple of friends over, right? And you want to share with them your cookies, right? So you've made 17 cookies, you have 3 friends visiting you. How would you split this amongst them, right? Typically, we would expect that you would want each one to have a cookie as a whole, not split into parts, right? So that's what we're going to do here, and we're going to use this floor division, which is the 2 forward forward slashes. So I would say total cookies are 17, friends equals 3, so our variable friends is equal to 3, our variable total cookies is 17, and then cookies each equals total cookies divided by friends, and then would ask Python to print the cookies each, right? So cookies each is this variable here, which we get by getting the total number of cookies, 17, divided by the number of friends. Let us go ahead and run this code. So when we run this code, notice here that we get 5, right? So what that is meaning is essentially each of our friends is going to get 5 cookies. We will have remainders, of course, but we're not interested in those because we're not interested in splitting up whatever number of cookies remain, right? So everyone can pick 5 and there will be enough for everybody, even though we have some remaining, right? The remaining ones will not, anyone can choose to take the remaining ones. You don't care. What you care more about most is that at least someone gets almost the same amount when they start dividing, right? So uh, as a quick note here, I'd written, so each friend gets 5 cookies, the remainder, the 2 cookies is ignored, right? So with negative numbers, the floor division still rounds down, not towards 0, right? Let us say you have a number, right? -7 divided by 2. This one here, if we do run it in our code, let us do just that. So we do see that we get -4, right? And where do we get -4? This is because when you divide this, you get -3.5, right? But when we round it down, it goes to -4, right? All right, let's look at exponentiation then. So we mentioned that we use exponentiation to raise the left operand to the power of the right operand, right? So for example, a exponentiation b means a to the power of b, right? So we use the asterisk. So double asterisks is exponentiation, not times, right? If you wanted to multiply, you just use one asterisk. So let's look at a code example for this one, right? I'll just go ahead and copy all this code, and notice that we have multiple print statements here, which means it is 3 expressions that we're printing, and each of them is essentially its own code, right? So the first one is print to exponentiation of 3. We would expect a result of 8. Print 5 to the to the power of 2, would expect 25, and then print 10 to the power of 0, would expect 1, since any number amount to the power of 0 is always 1, right? So to test this, let's go ahead and run this Python file. And surely enough, here we see 8, 25, and 1, right? So 8 is the answer to this first code here, which is print 2 to the power 3. And 25 is the answer to this second print statement, which is 5 to the power of 2. And 1 is the answer to this one here, which is 10 to the power of 0, right? So we do see that this code is running correctly. All right, let's look at another real world example, right? Now, let us imagine that we essentially wanted to take out a loan, right? I'll copy this as I explained. You essentially wanted to take out a loan, and that loan is in the amount of $100, right? So we would say our initial variable here is equal to $100. And then whoever's giving you the loan said, okay, you're going to be paying 10% interest every year, right? So we would call that the growth factor. So we'd say our growth factor equals 1.1, right? And you take out this loan and you say, you know what, I'm going to take it out for 3 years. After 3 years, I'm going to pay you back, right? So after 3 years, the question becomes, how much are you paying back, right? So we'd write our variable years as 3, right? And the formula that we would derive for calculating that would be essentially the amount to be paid at the end of that time, at the end of the 3 years, would be the initial, right? Our initial amount here, 100, times the growth factor, right? Which is 1.1. Okay, notice that here we use brackets, right? Because we want the open brackets here. Essentially, we want this to be calculated first before we multiply it by the initial, right? So that's essentially what we're telling Python to do. So we'll be getting essentially the growth factor, which is the 1.1. We'll be uh, we'll be powering it by 3. So it's going to essentially be 1.1 over 3 years. What it's essentially saying, it's 1.1 times 1.1 times 1.1, right? Because that's the growth factor over 3 years. And then we'll be multiplying that by the initial amount that we borrowed, which is the 100. And then we'll be printing that amount, right? Because these variables already store these values, we don't have to write the values here, right? So whenever we call these variables, Python will know which values we are referring to, since we already assigned them here previously, right? Let us run this code here and see what we get. We do get 133.1, which is this number that we expected, right? So that is how much we would be paying back at the end of the term, at the end of 3 years. So assuming we were only interested in the interest, right? Um, so how would we calculate that interest? Essentially, we would say interest is the amount minus the initial, right? Um, and then would go on to say, yes, please print the interest, right? And okay, so remember that we already have a value of amount stored to memory, right? Because amount is calculated by this function here, right? So to get in this formula, Python will essentially go back to this equation. It will calculate this and it will autofill it here. And then it will see that you want to subtract the initial. It will go back to your variable initial here. It will get the value of 100 and it will do the calculation, right, and store that to memory. And then when you say print, it will print that and show it to you in the console here, right? So let us run this and see what values we get. So notice that we have two print commands, right? And sure enough, here we have the 133.1, which is essentially the amount that would be owing at the end of 3 years in total. But second here, since we said print interest, this would show us the interest that we've accumulated on that amount since we took out the loan. So that is one real world example on how Python can essentially be used in software in financial institutions, right? These are things that we typically, your loans officer would typically calculate for you and give you the response in a couple of seconds, right? All right, let's cover operator precedence, right? We have looked at all these operators, and again, we started off from the previous video. We did cover addition, um, we covered subtraction, and we also covered multiplication here, right? We covered division. We covered the modulus, which was for the reminders. We covered floor division, which we use when we want our responses to be integers. And we covered exponentiation, right? Values to the power of other values, right? Now, whenever you run these um, expressions in Python, Python has an order of precedence, right? It prioritizes some before others, right? Remember, before we said that operations are essentially calculated from left to right, right? But let us explain how that essentially works. So the default order is most important first, right? So usually, even though most don't mention this, but like whenever you use the brackets, like this open and close brackets, in any equation or any expression, Python is always going to calculate that first, right? and get the value of whatever is in there, so that whenever it goes back to going to calculating from whatever comes first to the last, it is calculating that value already calculated. We'll see an example of that in a bit. And then, but typically without this, would expect that exponentiation would come first, and then would have the multiplication, would have the float division, integer division, or the modulus. And then we would, after that, we would have the plus, which is the addition, and then we'd have subtraction coming after that, right? So operators on the same line are evaluated from left to right, okay? And looking at this example that we have right here, if you wanted to calculate the result of 2 plus 3 times 4, because this is being calculated from left to right, but in the order of precedence, we would expect this to first calculate 3 times 4, right? And then after getting the 12, it would add the 2, right? Because we said that times comes first. Let us run this and see if it's going to calculate it exactly like that, right? So we're going to run this code, and notice here that we get 14, right? So despite the plus, despite of the fact that the plus comes first, because if it had done it this way, then it would essentially have been 2 plus 3, which is 5. 5 times 4 would have been 20. But that is not the way we do calculate this in typical mathematics, even in school, right? So essentially, Python does follow the same mathematical convention in that it will get to multiply first, and then it will add whatever value is being added to whatever has been multiplied. Let us look at the second example here, right? So we have this code here already written. You can pause and write it on your end and run it in your VS Code if you want to try it out and practice along. So let us look at this one. So this one says, okay, we are emphasizing by using these brackets, first add 2 plus 3, right? After you get the value of that, then multiply it by 4, right? So notice that in this case, Python is not going to try to multiply this 3 by 4 first, right? Because you have already specified and are clear that you want this to be added first. So it's going to first add this 2, it's going to get 5, right? So only after adding that 5 will it then follow its usual precedences, which in this case, since there's only multiplication first, it will do that first. And then that will be 5 times 4, which will give us a result of 20, right? So let us go ahead and print that out. And sure enough, here we do see our response, our result is 20, right? Let's go back here. So whenever you're in doubt, always use parentheses to make your intentions clear to Python. That's both safer and more readable when others are also reviewing your code, because they can easily note what you want to achieve. All right, so to close this, we're going to focus on building a quick mini calculator, as we promised at the start of the last in this video. And we're going to do so by using essentially the same pattern that calculators do use on a day-to-day whenever you want to calculate anything with them. So I'm going to write, I already pre-wrote this code here, but I'm going to first explain it to you, and then we're going to run it to see the results. Notice here that we're doing something that we haven't done before, right? So first thing we do is we're assigning these two variables values, right? So we're assigning variable A a value of 15, variable B a value of 4, right? And so after that, we're saying print, right? So this is our first line of code. Let me first do this one first so that I'll come back to it later so that this long thing doesn't confuse you. All right, so here when we say print A equals A, what are we essentially doing? Notice that Python is essentially going to keep this as a string, right? So whenever we do in a print statement, whenever we put something in the open quotes, like this, equals, right? Or we could even write it out as equals, Um, what this is essentially telling Python is that when you're printing this command, whatever is in the quotes, you just return it as a string, the same way I've written it, right? But notice that whenever, so this is separated by a comma, right? Since it's in open and close brackets. Notice that whenever we put a variable that we've already defined here, it automatically identifies it as a variable, and it's in the same colored code, right? So A here is in blue, same to this one is in blue, right? Um, so this is going to return the value of this one, right? So we expect that whenever we print, it's going to print A equals A. Let us run that. And surely enough, in our terminal here, you see that A equals 15, right? Which is the value of A that we already defined, right? So this is essentially what all of this code that I wrote here is doing, right? To mimic a calculator. Um, so um, since of course we don't have the equals button, so that would be our way of assuming we've pressed the equals button, right? So let us say you are typing into your calculator, right? You have your value A and your value B, right? um, Printing your value A would return 13. So if you just typed in 13 in your calculator, it would return 13. If you wrote 15 and you said print 15, or I mean print B, which is 4, it would return the value 4, right? But if you went ahead and actually made a calculation, right? So for example, you typed in your value of A, which was 15, and you added plus B, which was 4, and you said print A plus B, right? You would expect to get a value which is the sum of those two values, and this is what you get here, right? So on our console, it's saying A plus B equals 19, right? So it's calculating that as a calculator would. What if you actually wanted to subtract, right? So A minus B equals 11, right? Again, if you check here, 15 minus 4 equals 11, right? What if you wanted to print A times B? So A times B, that would be your value of A times your value of B, which would be 60 as it's printed out here, right? What about if you wanted to calculate um, A divided by B by using the float division, right, which is the single forward slash, then you would essentially be getting the 3.75 right here, right? Notice that it's using decimal points. What if you wanted to find the remainder, right? So A modulus B would essentially be 3, because 3 times 4 is 12, and 12 is 3 values away from 15, so that would be your remainder. And A modulus B, meaning you want to calculate A divided by B, but you're not interested in the remainder. That would return your A modulus B here, again, using these variables. And it would give you the value of 3. Same as A exponentiation of B, right? So you're saying print A exponentiation B. Again, it runs those values. It doesn't run these ones because they're just strings. Essentially, you're naming whatever you want to be displayed on the console. It multiplies this one, and you get your value of yeah, 50,625, which is the answer you'd get if you put this to the power of this in a calculator, right? So there you go. That's a simple calculator. If someone asked you to write code for a calculator to test if you can write essentially write the code for that in Python. On its simplest level, you would essentially write code that looks like this, right? Though you can make it as complicated as you want to be, right? So we're going to try out a little advanced version here, and we're going to start using input, right? And I'm going to explain what input means in a minute. Before I do that, let me just copy this code here and put it right here. And again, as usual, I'm going to first try to reduce it so that it's not that confusing. So I'll add this in a second. Let's first work on this first piece of code. All right, so again, as usual, so as we've looked at prior, I'll comment this one out. We've noted that usually whenever we are assigning a value to a variable, we're going to write something as A equals a equals 5, right? And then we also going to write like a, b equals 10, right? Now that is assuming we already have fixed values, right? So what if, and again, going off of a typical calculator, whoever writes the value, I mean the code for the calculator doesn't know what operations or calculations you're going to be making, right? So that means that whenever they write the code, they should write it to run with whatever values you're going to be entering into the calculator next, right? Because that varies depending on the user at any point in time, right? So let's say uh, user A is calculating the square root of 50, user B is calculating the sum of a million plus 2 billion, right? So these are all different use cases. So the way you would approach writing code for such a calculator is you would give it the ability to ask the user for the input that they want to calculate, right? So let us say um, user A is going to enter the first number and then they're going to enter the second number. What input is essentially telling Python is you're going to expect an input from a user, right? And we can see this repeating in both lines of code, right? So we're saying you're going to expect an input and it's going to be an integer, right? And on the console, you're going to essentially, um, so here when we're saying print, we're going to say on the console, you're going to print this. Notice that it's a string, right? So this here, enter first number, is going to be printed on the console so that when a user sees that, they will know, okay, I need to write that number, right? So for example, 1 or 2. And once they're done with that, you're going to also ask them to give you the second number. And once they have written that, then you're going to calculate whatever they're calling for, right? So in this case, we're saying a plus b, if that is what they're calculating, right? Um, so let us run this first command here and see what we get, right? This here is going to be ignored because it's in green, so don't care about this, just care about all this other code, right? So we've said a equals integer, input, enter first number, right? So so input here, right? Let us say we put b, right? Notice that it automatically returns an error and says there's an error um, uh, in your response, right? And check line 1 because it says input, enter first number as an integer, right? So to correct that, we would need to essentially run that as um, we would have to actually use a number that was an integer, right? So we're going to do that and enter 56, for example, right? And then it's going to ask us to enter the second number running this line of code, and we're going to enter 20, right? Now, since this here is asking it to print, right, a plus b, or the sum of a and b, is going to print this, right? So this code, you can assume, is the one is more like also partly either user interaction. You could write the code to make it that way so that the user chooses what they're actually calculating, or you could have it in a way sort of like set for them, right? Because you expect that whenever they use that calculator, they're looking for the sum of two different values, right? So they enter the values, you automatically calculate them for them, right? Let us add more code here, right? So here we're anticipating whatever they want to do. So we're saying, okay, the plus, again, we're keeping this very simple, right? Well, what these buttons are essentially doing is we have the plus button, which would add the values, the minus button, which would subtract, the multiplication, the division, remainder, exponentiation buttons, just like you have on a calculator, right? And again, we're keeping it very simple here. So whenever we say print a minus b, it's going to print and give us the value of that. Multiplication, same thing. Let us run this code and see what we get, right? So notice that it's asking us for the first number. Let us say our first number is 5, right? And it's asking for the second number. Let's say it's 2, right? So it runs the calculations, and surely enough, here we see that a plus b is 7, right? So if we're to get 5 plus 2, that gives us 7, right? A minus b is 3, right? So if we to subtract 2 from 5, would get 3. A times b is 10, right? So the same here. A divided by b using float division is 2.5. A modulus b is 1, right? Divide 5 by 2, you get 2 remainder 1, so that's our remainder. A divided by b using floor division is 2, gives us a whole number. And then a to the power of b is 25, right? So if you get 5 to the power of 2, you'd expect a value of 25. So the code did execute correctly, so there is no issue with this code. And you can definitely always use this as the simplest version of building out a calculator. Of course, if you want to make it more complicated, you're welcome to build onto this one here. But I hope this covers everything that you wanted to learn about essentially operations in Python. In the future videos, we'll be exploring other things like expressions and importing data within your code or opening files. But for now, that should be enough to get you started. And be sure to watch the next videos in the playlist to advance your skills. And hopefully soon you'll be able to work on projects, and whether it's just typical legacy projects or you want to explore with AI projects as well, I will be covering more code to help you with that. All right, we'll see you in the next video.